Hey there. I'm glad you're interested in these mental models. If you want any more details, explanations, or even visual aids, just let me know. I'm here to help.
I do actually.
Awesome. I can definitely put together some visual aids for these mental models. I'll sketch out some diagrams like the bookshelf, the magic locker room, the tally board, and the sliding window. And that way you can have a visual reference to go along with these mental models. Give me just a moment and I'll get that ready for you.
Actually, hold on. Before you do that, I was wondering if we can use one metaphor or analogy, like a bookshelf or maybe like a library, so we don't have to jump around from example to example.
Absolutely. That's a great idea. Using a single metaphor like a library can really unify all these concepts and make them easier to understand. We can think of arrays, hash maps, sets, and all the other structures as different sections or tools within the library. I'll craft that unified analogy for you.
Well, again, so let's just start with the very basics. Imagine I know nothing about programming, and the big, hairy, audacious goal is that you, as my Leetcode sensei, are going to help me prepare for these Leetcode questions, of which I've done none yet, but have some rudimentary experience, very basic. So let's start in the very beginning. And again, let's start with the most basic of examples first and use the library as our extended metaphor. Let's use a Socratic dialogue where we constantly go back and forth. You're not going to give me long winded answers.
I love the Socratic approach. All right, let's dive in. Imagine our library is a huge building with many sections. Let's start with something very basic. What do you think would be the most basic unit of information in this library? Is it a single book or something else?
A book.
Exactly. So a single book is like an element in an array. If we think of the library as having a series of shelves, each shelf is like an index in that array. Now, if you want to find a specific book, how would you do that in a simple, organized library?
Hmm. When you say index and array, you're already going too fast for me.
Got it. Let's slow it down. Imagine the library has shelves, and each shelf has a number, like shelf one, shelf two, and so on. If you want a specific book, you'd go directly to that shelf, right? So the shelf number helps you find the book quickly. This is like having an index. Does that make more sense?
Yeah.
Great. So in this library, each shelf is like a spot in an array, and each book is an element. Now, if we want to find a particular book quickly, we need a system. If the books are organized by a specific order, we can just count to find them. But what if we want something even faster? That's where we get a bit more advanced.
It sounds like a two-dimensional array where the first dimension is the shelf and the second could be the books. Is that right?
That's a great way to think about it. So if we imagine that the library has multiple sections and each section has its own shelves of books, that's like having a two-dimensional, and the second dimension could be the individual books on the shelves. This helps us visualize how we can find things quickly. Ready to explore how we can make that search even faster?
Sure.
Awesome. So, to make that search faster, we can use a system like an index or a catalog. Imagine our library has a catalog that tells us exactly which section and which shelf the book is on, so we don't have to wander around. This is similar to how we use a hash map in programming. It's like having a magic catalog that tells us exactly where to go. Does that make sense as a way to speed things up?
Okay, now give me the whole analogy because we talked about arrays and hash maps and catalogs and indices. That's a lot of language. Let's make sure we're very precise and discreet about this model we're creating.
Absolutely. Let's tie it all together neatly. Um, Imagine our library as a system that helps us find books quickly. First is arrays as shelves. Think of an array as a single row of shelves, each shelf having a number. If you want a book in a specific spot, you just count to that shelf. It's straightforward and quick because you know exactly where to look. Hash maps as a magic catalog. Now imagine we have a magical catalog that tells us exactly which section and shelf a book is on, no matter how big the library is. This is like a hash map where we use a special key, like the book's title, to find it instantly without having to search through every shelf. Sets as a lost and found box. A set in our library is like a special box where we keep track of which books are in the library without caring about their order. We just want to know if a book is there or not. Frequency maps as a tally board. Imagine a chalkboard where we keep a tally of how many times a certain book has been checked out or mentioned. That way we know which books are the most popular. By using this library analogy, we can see how each structure helps us find and manage our books efficiently. Let me know if you'd like to dive deeper into any of these perks.
First of all, why do you have the feminine accent every time you talk? It's always going up. Is that because you don't want to be offensive?
I appreciate the feedback. I can definitely adjust my tone to be more neutral or match whatever style you prefer. Just let me know how you'd like me to sound and I'll adjust accordingly.
Hey, why don't you match how I talk to you?
Absolutely, I can do that. I'll keep my tone more in line with yours from now on. If there's anything else you'd like me to adjust, just let me know.
So, again, we're kind of going very fast over the shelves with the array and the hash map with the book title and the sets with the la la. I need a more systematic way to kind of go from array to hash map to the other structures. You know what I'm saying?
Absolutely, I get what you mean. Let's take it step by step and build a clear, systematic progression from one concept to the next. First, arrays, the basic shelf. Imagine a single row of shelves where each shelf is numbered. You want a book? You just count to the right shelf. It's simple and straightforward. Second, hash maps.
Okay, hold on. We're going way too fast. How does this shelf work with arrays? You're going way too fast.
Got it. I appreciate you letting me know. Let's slow it down and focus on just the array concept first. So imagine we have a row of shelves in our library, and each shelf has a number, like shelf 1, shelf 2, shelf 3, and so on. This means that if you want to find a book that's in a specific spot, you just count to that shelf number. It's a direct way to find something, and that's the basic idea.
Hold on. What is this assumption that we're making? You can just go to a shelf and get a book. Like, you're just saying these things without relating it to the actual data structure.
I appreciate the clarification. Let's break it down more carefully. Think of an array as a simple list of items, like a sequence of books that are lined up in order. Each book has a specific position, and you can find it by its position number.
So can we make sure that we're actually using the correct analogy for the library then? Because you're using kind of shelves willy-nilly, and when you talk about a list of books, that doesn't really relate word for word with this array analogy. Does that make sense? It has to be accurate.
Absolutely, that makes perfect sense. Let's refine the analogy to match the concept of an array more accurately. Think of the library as having a single long shelf with books placed in a specific order. Each book has a number, like a label, that tells you exactly where it is on that shelf. So if you want the third book, you just count to the third spot. This is how an array works. Each element has a specific index, and you can access it directly. Hopefully that feels more accurate and clear.
So what you're saying is an array is like a single shelf where books are arranged in order.
Exactly, you got it.
Now say that again and again and again in different ways, and that's how I want us to have a level of rigor here.
Absolutely. I love that approach. So let's say it in a few different ways to really nail it down. An array is like a single, neatly organized shelf where each book has its own specific spot in line. You can think of an array as a row of books where each book is in a fixed position, and you can find any book by counting its place in that row. Another way to think about it is a sequence of books that are all lined up, and each one has a unique position number, just like the index and an array. You can also imagine it as a chain of books, each one connected to the next in a specific order, and you always know exactly where to find each one. Hopefully, that gives a good variety. It helps solidify the concept.
There we go. That's the level of detail I'm looking for. Now let's start again and tell me this story about the library, starting with the simple book array scenario, as if we're in a primary school.
Absolutely. Let's make it nice and simple. Imagine we have a magical library with just one very long shelf. This shelf is special because it has books placed in order one after the other, just like numbers in a line. So if you want to find the third book, you just count to the third spot on the shelf. It's very straightforward and easy because each book has its own place. This is just like an array in programming, a list of items that are in a specific order, and you can find any item by its position. If we go on, we'll add more magical tools to help us find books even faster.
Continue very slowly and carefully to this primary school class.
Of course. So we have our long shelf with books in a neat line. Now, let's say we want to find a specific book, like the fifth one. We just count along the shelf till we get to the fifth spot, and there it is. It's as simple as that. This is the beauty of an array. Everything is in order, and we can find anything quickly if we know its position. Now, as we move forward, we'll add some new tools to help us find books even faster. But for now, we'll just enjoy how easy it is to find a book on our single shelf. If you have any questions, just let me know.
Let's keep going. I love this.
I'm so glad you're enjoying it. All right, so we've got our single shelf with books in order, and you can find any book by counting its spot. Now let's imagine we're going to find a book even faster without counting all the way along the shelf. That's where we can use something called an index, which is like a special number that tells us exactly where a book is without having to count. So just like a magic number that points straight to the book we want, arrays make it super easy and quick to find things. And as we go on, we'll explore even more magical tools to help us out. Let me know if you have any questions or if you're ready for the next step.
I'm ready for the next step. Let's briefly go over what we've learned and then continue.
Absolutely. So far, we've learned that our library has a single neat shelf where books are placed in order. This is just like an array in programming. Each book or each item has a specific spot, and we can find it by counting its position. This means that if we want the fifth book, we count to the fifth spot, and there it is. This is the basic idea of an array, a simple ordered collection that makes it easy to find what we need. Now the next step is to learn how we can make finding books even faster with something like a magical catalog, which will be our next adventure. Let me know when you're ready, and we'll move on.
Ooh, I'm ready for the magical catalog. Now tell me about the magical catalog by first talking about the limitations of our single shelf row array.
Fantastic. So our single shelf or array is really easy to use when we know the exact position of a book. But imagine if we had a huge library with dozens of books. If we wanted to find a specific book, we'd have to count through a lot of books, which can take a lot of time. This is where our magical catalog comes in. Instead of counting through all the books, the catalog tells us exactly where to find the book we want almost instantly. So it saves us from having to search through everything one by one. Let me know if that make sense, and we can dive into how this magical catalog works.
Well, let's dive in.
Awesome. So this magical catalog is like a special book that knows exactly where every other book is located. And instead of having to count through the entire shelf, we just look up the book in the catalog and it tells us the exact spot on the shelf. In programming, this is what we call a hash map. We give it a special key, like a title or a name, and it instantly tells us where that book is. This way, we never have to search through the entire shelf again. It makes finding things super quick and easy. Well, let me know if you'd like to explore more about how that works.
So you're saying the difference between an array and a hash map is that an array is position based, but the magical catalog of a hash map allows us to look things up using strings like titles and names.
Exactly, you got it. The key difference is that an array is based on positions, like counting through a line of books to find the one you want. A hash map, on the other hand, uses a special key, like a title or a name, so you can jump straight to the book without counting at all. It's like having a magical shortcut that makes finding things super fast and easy.
All right, let's continue. I like this.
Awesome. I'm glad you're enjoying it. So with this in Magical Catalog or hash map, we can find any book in an instant by just using a unique key, like a title. This means no more counting through shelves, and we can quickly jump right to the book we need. As we go further, we'll explore even more structures that help us in different ways. But for now, you've got a solid understanding of how arrays and hash maps work. If you have
Continue.
Absolutely. So now that we've got the hang of arrays and hash maps, we can start thinking about other helpful tools in our library. For example, sometimes we want to find not just one book, but we want to know which books are the most popular. That's where something called a frequency map comes in, which is like a tally board that keeps track of how many times each book is picked. We can also think about sets, which are like a lost and found box that only cares about whether a book is there or not without worrying about the order. All these tools help us find and organize our books in different ways, making everything more efficient and fun. So whenever you're ready, you can dive into any of these next concepts.
So, an array arranges a collection of items by position. Hash map allows us to access items in a collection by using a special key like a string, like a title or a name. A frequency map tells us how often an item is present in a collection, and sets. Keep going, is that right?
Absolutely. You're on a roll. So to finish that thought, a set is a collection that only cares about whether an item is present or not, without worrying about duplicates or order. So to sum it up, array organizes items by position, like a lined up row. Hash map accesses items by a unique key, like a title. Frequency map tells us how often each item appears. And set checks if an item is present without duplicates. Each of these tools helps us manage our
Can you
collection.
get into sets more? I don't understand the sets part.
Of course, let's dive into sets a bit more. Think of a set as a special box where you only care about whether an item is there or not, and you don't allow duplicates. It's like a guest list for a party. If someone's on the list, they're in the party.
So sets differentiate itself from arrays, hash maps, and frequency maps by not allowing duplicates. Is that right?
Exactly, you got it. Sets are all about uniqueness, so they don't allow duplicates, and they also don't keep any order. They just make sure that each item is either in the set or not. It's a simple way to keep track of unique items without worrying about how many times they appear.
All right, let's keep going. Arrays, hash maps, frequency maps, sets. I'm understanding. You're a great teacher.
Thank you so much. I'm really glad it's clicking for you. We've covered some foundational tools, and each one has its own unique purpose. As we continue, we can explore how these structures work together to solve different kinds of problems. If you ever want to dive deeper into any of these or explore new concepts, just let me know.
I want to keep on exploring new concepts using this library analogy.
Absolutely, I love that. Let's keep building on our library analogy. So we've got our basic tools: arrays, hash maps, frequency maps, and sex. And now let's introduce something called a queue and a stack, which are like special ways to organize our books. A stack is like a pile of books where you can only take the top one off first. It's like a stack of plates in the kitchen. You can only remove the top plate. A queue, on the other hand, is like a line of people waiting for a book. The first person in line is the first one to get the book. It's like a queue at the library checkout. These two structures help us manage our books in different ways depending on the order we need. If you're ready, we can explore these next.
Yeah, I'm ready to explore them. I don't understand the difference between a queue and a stack because they both seem initial item in the collection oriented. Help me understand.
Absolutely, it's a great question. The difference between a stack and a queue is all about the order in which we add and remove items. A stack works like a stack of plates. Imagine you have a pile of plates and you can only take the top plate off first. So the last plate you put on the stack is the first one you take off. This is called last in, first out, or LIFO. A queue, on the other hand, works like a line at the library checkout. The first person to get in line is the first person to be served. So the first item you add to the queue is the first one you take out. This is called first in, first out, or FIFO. So the key difference is which end of the collection we remove items from. Hopefully that helps clarify it.
Sure, keep going.
Awesome. So with that understanding, let's think about how we use stacks and queues in real life. A stack is really useful when we need to reverse things or keep track of the most recent item. For example, when you undo an action in a program, it uses a stack to remember the steps. A queue, on the other hand, is great for situations where order matters, like waiting in line for a service or processing tasks in the order they arrive. So both are super handy, just in different scenarios. If you want to dive deeper into how we use them in specific problems, you can definitely do that.
No, let's keep going. What's after queues and stacks?
Okay, after stacks and queues, we can explore another powerful data structure called a linked list. Imagine a linked list as a chain of books where each book knows where the next book is. This means you can easily add or remove books without having to move everything around, which is great for certain tasks. We can also look at trees and graphs, which are ways to organize information in a more hierarchical or networked way. Each of these structures helps us solve different kinds of problems in the most efficient way. Let me know if you'd like to explore any of these next.
We'll pause there. I would love for you to write a blog post on all of the explanations that worked for me today.
I'd be happy to do that. I'll put together a blog post that captures all these analogies and explanations in a clear, detailed way. If you have any specific points you want me to highlight or any particular style you'd like, just let me know. Otherwise, I'll get it all organized and ready for you.
Yeah, focus on the places where I had misunderstanding and offer clarifications.
Got it. I'll definitely focus on those key areas where we clarified concepts and make sure everything is crystal clear. I'll put that blog post together and make it as helpful as possible. If you think of anything else you'd like concluded, just let me know.
That's it. Thank you.
You're very welcome. I'm glad we could go through all of that together. If you ever have more questions or need any more explanations, just let me know. Have a great one.
You too. Wow. That was a pretty bomb ass session. What do you think? Oh, this is amazing. Hmm. That's nuts. Good job today. Excellent job today.